In a football tournament, points are awarded as follows: 3 points for a win, 1 point for a draw, and 0 point for a loss. They want us to write a 3x1 matrix P to represent this information. Now, 3x1, so they're already shaping this matrix for us, 3x1, which means 3 rows by 1 column, right? Which means we're getting a 3, a 1, and a 0 for this matrix. So this is a 3x1 matrix where this is row 1, row 2, and row 3, and this is just column 1, right? So we're talking about that is a 3x1 matrix for 1 mark right there. Now, the follow-up question says, during the tournament, Team Alpha recorded 5 wins, 1 draw, and 3 losses, while Team Beta recorded 3 wins, 4 draws, and 2 losses. Write a 2x3. So they're giving you the shape, all right? The order of the matrix, 2 rows, 3 columns, 2x3 matrix, because rows come before columns. Team Alpha, 5, 1, 3, and Team Beta, where is it? A 3, 4, 2. That is our 2x3 matrix. Check it out. Row 1, row 2, and then we have column 1, column 2, and column 3. So there it is. We're looking at a 2x3. And the top row refers to alpha. The bottom row refers to beta. Calculate the matrix product, all right, RP. All right, so this is called, this one that we just did is R, and the other one that we did is P. So we have to put the things in the right context. We're talking RP. R is 5, 1. Let me create some more space. Talking about 5, 1, 3. Then we have 3, 4, 2. All right. That is matrix R. And then matrix P was a 3, 1, 0. That's a matrix P. So there it is. So we would have had those. Calculate the matrix product. So we're going to multiply. Remember, I know when you multiply, it's row by column, right? So what we're going to have is row 1 will multiply. So let me highlight row 1. Then we have row 2. And then this is just one column, column 1. So we could look at row 1, row 2, and then column 1. Now, remember, you multiply row by column, and you're multiplying corresponding elements in the rows with corresponding elements in the column. For example, the first element, so 5 will multiply by 3. So 5 is the first in row 1, and 3 is the first in column 1. And you're going to be adding everything. So 5 times 3 plus 1 times 1. I'm using row 1 to multiply by column 1. And then we have a plus 3 times 0. So that's 1 working out. 5 times 3 plus 1 times 1 plus 3 times 0. Then now row 2 will multiply by column 1. So it's going to be 3 times 3 plus 4 times 1 plus 2 times 0. And then finally, the numbers, we're talking about 15. Then we have plus 1 plus 0. And then underneath, you have 3 3 is 9 plus 4 plus 0. Finally, 15 plus 1 plus 0, 16. And and then 9 plus 4, 13. There it is. So alpha represents for the top and beta for the bottom, right? All right, so we got our 2 marks there, matrix multiplication. Now, what does the matrix product represent? This would have represent, so the matrix product represents the total points scored by each team, where team alpha got 16 points and team beta got 13 points. Right. Let's look at this other one here. It says the value recorded in the table below represents the velocity of an object over a period of time. All right, so the velocity of an object over a period of time. So we're seeing velocity at 20 with 5, and then velocity was 34, time was 12, velocity was 46, time was 18, velocity was 60, time was 25. So we're seeing those. So on the grid below, 2 points are plotted. So we're going to be looking at those. So they plot 2 points already for us. Plot the remaining 2 points on the grid and draw the line of best fit. All right. So the question says on the grid below. So on the grid below, 2 points are plotted, and we want to plot the remaining points. Right? They plot 5 and they plot 18. All right. So we would have to plot. So they plot this and this. So we're going to plot 12 with 34 and 25 with 60, right? So we're going to plot those. And let's make sure that we have them. We could switch back to them. 12 with 34. All right. So one has to, we have to look on the grid though to see what's what. 12. So basically, if I should blow this up for us quickly, like that, just to look on the scaling. Now we're paying attention to here. That's 10 and this is 15. So there's 5 between this. So you could see that this is 1, another 1, another 1, another 1. So you could see that this is 11, then 12, and 13, and 14 going to 15. So every 2 lines is 1, right? So 12 is actually that line, right? So we can see that. And so that's on that axis. But when you're on the other axis, there are 10 lines from 0, 10 little lines from 0 to 10. So each one of these is a 1. So that means this is where 5 is, this is where 15 is, and we can easily navigate this axis here. Because 1 line on the y-axis over here is actually 1 unit, while 2 little lines will refer to 1 unit on the x. So let us plot 12 with 24. So I could follow the 12, go up, 12 with 34. So 12 with 34 is going to be right here. That's 12 with 34. And the next one is 25 with 60. And they said, draw the line of best fit. So a line of best fit right there. So we just simply plot the points and draw that line. Let's go back to the diagram to see what we have. All right, the next question now says, so we are at this. It says, given that the linear motion of the object can be expressed as v is equal to u plus at, which is this, where a and u are constant, and constant there mean they're just numbers. So a and u are numbers. So v and t will be there as v and t, but a and u will be some number. All right. Use the graph to determine the value of a and b. When they say use the graph, it means that we have to interpret the graph. All right. So I'll use this idea v is equal to at plus u. All right. All right. So v is equal to at plus u, and I want you to think about this. Y is equal to mx plus c, where m is going to be like the v and the u is going to be like the c. And just as though y and x are just the variables on the y and the x-axis, so it is that the velocity and the time are the variables on the y and the x-axis. So definitely we can lighten that onto our gradient. So that is the gradient. We can pick up the gradient a number of ways. We're going to be looking at that right now. So this is referring to the gradient. So when I find gradient, I'm finding A. And when I find my y-intercept, I am finding U. There it is. Now the y-intercept already is 10. So let's look right here. You could look, take a good look. 10 is where that graph crossed the y-axis. So then currently we could say that U is equal to 10 right there. We're interpreting this from the graph, right? Where the graph crosses the y-axis, that's our y-intercept, and it is lightened onto the U, which is like the C, is a straight line. The gradient of the line, though, we could pick up that by quickly creating a right angle triangle. So now let's take into consideration, though, the units that we're dealing with. So based on the scale, look at the numbers on the x-axis. So we're going to be looking at the numbers. Look at this number here, 5. So I'm going to pick up a point here. And look at 15. I'm going to pick up a point here because I'm able to get out some nice numbers. So I'm not able to, I don't want to pick up anything where I'm going to get any decimal. So I'm picking up from here, changing this to a purple. And then I'm picking up from there, come back down here. Changing that to a purple. Then now we're checking out this. Now we're moving from 20 to 40. So this is like 20. This is 40. So the length of this is 20 units. So thinking about that, 40, take away 20, you're left with 20. And that is how we would have worked out that 20. Now we have to pay attention to this. This is 5 and 15. So 15 minus 5, that means this length is 10. So this is 10 units right here. So we have to be careful with the scaling. Okay, you don't want to count and say 1, 2, 3, 4. Like a lot of people would have said 1, 2, 3, 4, 1, 2, 3, 4, and say 4 over 4. But no, you can't just do that because the scaling will determine the numbers you pick off. So you have to be careful. So now this value of A is our gradient, and it's going to be rise over run, which is 20 over 10, which is equal to 2. Right? So then the value of A is 2, and the value of U is 10.